Hey everyone, in this video we're going to go through the week 2 test. So please make sure when you listen to this video that you're also going through your test. And if you get a question incorrect, just make sure you understand the solution. And even if you get a question that has the correct answer, it's worthwhile watching to make sure that your method's correct, because sometimes we can get an answer that looks correct or is the same, is a correct answer, but our method is incorrect. So you need to make sure that your method is correct in order to get the marks. All right, so in question 1, we were just looking at literal equations, and this first one, it was quite surprising the number of people who could not work with fractions. Now, if I was to give you a simpler question, oh, that's not working, say 1/2 plus 1/3, you could do that. You'd be like, oh yeah, I know I need the same denominator. So you would change your denominator to be 6, so your lowest common denominator, and so we basically say, what do we do to get to 6? We multiply it by 3. So whatever we do to the bottom, we do to the top. And then we've got to change this one. So 3/6 plus 2/6 is 5/6. And you're probably sitting there and be like, yeah, I know that. It is exactly the same in question A, but the number of people I saw write x plus x on the top and a plus b on the bottom. That is not how you deal with fractions, and I really want to see that that being the last time that you do that. You need to be able to deal with fractions a lot in methods. They pop up all the time, especially when we're doing probability. So make sure you can deal with fractions. Okay, so we're adding fractions that have a different denominator. So what we need to do is make them have the same denominator. Unfortunately, my pen's like frustratingly, oh, there we go. Okay, so our common denominator is going to be AB. All right, it's exactly like we did before, and I've rubbed it out already. But remember, to change it to the 6, I just multiplied it by a number. So here, for our first fraction, we're multiplying it by b. So b on the bottom and then b on the top. Okay, so b over b, the whole reason we do that, it's still equal to 1. It's kind of like a fraction in disguise. We haven't changed the value of it. It just looks slightly different. And then, so if you were writing it, you could probably write little times b, and then your other fraction, we're going to be multiplying it by a over a. So just to be consistent, let's change that to bx. Doesn't really matter. And then that is equal to 1. Now that we have the same denominator, we can bring those fractions together. And it's so weird. I'm sitting here doing this and actually doing the hand movements. You can't see me saying bring these fractions together and moving my hands together. Okay, so now we have the same denominator, add the fractions together. Now it's an equation we can solve. So we want to get rid of that AB on the bottom, so we multiply both sides by AB. So 1 times AB gives us AB. And at this stage, I'm like, oh my gosh, we've got like these A's, these B's, these X's. Remember, we're solving for X, so we just take X out as a common factor on the left-hand side and leaves us with B plus A. So if you've got ever got multiple terms with X or whatever your variable is that you're using, just take it out as a common factor, or factorize it if it was a quadratic. It's just going to make it so much easier for you to solve. All right, so now we're going to divide both sides by B plus A or A plus B. Oops, I've got the plus sign in between. I'm going to do A plus B just because I like a bit of like to be in alphabetical order. So they cancel out. So X is equal to A times B over A plus B. So you would be able to do this if we didn't have numbers. Sorry, if we didn't have letters. We had numbers instead of letters. So same fraction rules apply. All right, you probably know that. All right, but I don't want to see errors made with fractions. Okay, fractions shouldn't be the thing where you get questions wrong. All right, question B. Actually, I've got this. I'm trying to do this on the screen. I've got it on my phone as well, so I can look at my phone. All right, so for question B, what do we got? P times X plus Q times X equals P squared plus 2PQ plus q squared. I just realized then another common error I found was people cancelling things out. And you can't cancel out unless there's a common factor. So if we look at this final answer here, I can't say that that b cancels out with that. All right, they don't cancel out unless that b was a common factor. And what I mean by that is it was taken out of some brackets and then we can cancel it like that. Okay, so that was a common error I saw as well. So don't do that, please. It's very frustrating when I see people make that mistake. Okay, so moving along to b. So on the left-hand side, I can see straight away I'm going to take out x as a common factor. So we're left with x times p plus q in brackets. Now on the right-hand side, now it might not be immediately obvious, and that's kind of the trick to this one, but we've actually got the difference of, sorry, not the difference of perfect squares, we've just got a perfect square. So p squared plus 2pq plus q squared is an example of a perfect square. So it actually simplifies to p plus q squared. So if I was to expand that, I would get what is above it in pink. Now, when you did quadratics back in year 10, sorry, maybe year 9, but definitely year 10, and when you did it in year 11, you would have done perfect squares, the expansion of the perfect square. All right, so now I can divide both sides by the p plus q. So I've got on this side p plus q, and I'm going to expand that. Oops, let's be consistent, Karen. All right, p plus q. And then on the bottom we've got p plus q. So one of these cancels out with one of them. And why the whole thing can cancel out is because it's the same thing and it's being multiplied up the top. So x is equal to just p plus q, or if you had q plus p, same thing. All right, let's have a look at question C. I'm going to do that up here. I might go all the way up because you never know with these questions. Sometimes they take a lot of space. All right, so we've got a minus b over x minus c equals a plus b over x plus c. Now here, we don't need to have the same denominator, and the reason for that is because we're not adding these fractions. We've got one fraction on the left-hand side, one fraction on the right-hand side, but I do want to get rid of the denominators because things are a lot more easier if we just don't have denominators in our lives. So we do a cross multiply. So putting brackets around everything just kind of makes it a little bit easier to see. All right, because we're multiplying, if you didn't have those brackets, it's going to just really, really confuse things for you. So if I multiply both sides by x minus c, basically it goes from the left side to the right, and then the x plus c on the right side goes to the left. So I end up with a minus b still on that left side, but that x plus c has come over. And on the right side, I've got x plus b, and then that x minus c comes over. So now I've got rid of the fractions. I do have a bit of expanding to do, which is a little bit annoying, but skills that you definitely have. All right, so we get ax, so you know how to expand like that. All right, so a times x, a times c, minus bx, minus bc. And then on the right side, ax minus ac plus bx minus bc. Now, if you have the same thing on the left side as you do on the right-hand side, they just cancel out. So this ax cancels out with that ax. The ACs don't, because you've got a positive AC on one side and a negative on the other side, but we do have a negative BC and a negative BC, so they cancel out. All right, so now we're left with AC minus BX equals AC plus BX. Now, we are solving for x, so it's probably a good idea to put the x's on the same side. Only because there's a positive bx on the right side, I'm going to... Now, did I miss out on a negative? There should have been a negative there, silly me. All right, I'm going to bring that AC over to that side and the bx over to the other side. If you did it the other way, you're just going to end up with negatives. No, it's not wrong, so please don't think that, you know, there's only one way to do it. Okay, so we've got 2's on the same side, so they basically cancel each other out. And just dividing by b, we end up with AC over b. All right, question numero D, because D is a number, isn't it? Silly me. Okay, we've got 1 over x minus a plus 1 over x minus b equals 2 over x. Alright, so again, we cannot add those fractions together because we don't have the same denominator. So we've got to make them the same, just like we did in question A, where we multiplied, the first one by b over b. Our common denominator, and it's a bit of a long one, is going to be that. So x minus a times x minus b. Alright, so let's just set it up. Sorry, I'm doing it around the wrong way again. Alright, x minus a, x minus b. Okay, so with your first fraction, we multiplied it by x minus b over x minus b, so that goes there, and then x minus a here. And I'm putting brackets around it because we're going to be maybe doing some multiplying later, I don't know. Alright, and then we've got 2 over x. Now we have the same denominator, so I can add those two fractions together. Oh, why did I write a? Sorry guys, x minus b. And then on the top we have, now I don't need to have that bracket there anymore, but I am adding, if I was subtracting in the middle here, I would have to be very conscious of applying that negative to the x and the negative a. But it's a plus, so it doesn't really, it's not too confusing. Alright, so 2 over x. Alright, so we'll just see what we can do. I might get rid of that x on the right side. So remember also there's more than one way of doing things. So I'm just going to multiply that side by x, and then I'm going to multiply this side by x too. So when I multiply, I just make sure it's multiplying that whole numerator. Okay, so we're left with x times, now I've got 2x there, so I can bring them together, minus a minus b, just putting things in alphabetical order. And then on the denominator, I'm not going to expand them because I feel like I might have to keep them in factorized form, equals 2. I think I might actually end up having to, alright, let's expand everything. So I'm going to expand that numerator, so we get 2x squared minus ax minus bx, and I'm going to do 2 steps in one. I'm going to bring this denominator over to the other side, and I'm going to expand it at the same time. Alright, and it does, everything does have to be multiplied by 2, so I'm going to put it in bracket. So we have x squared minus, x, oh, what am I doing? Yeah, x squared minus bx minus ax plus, oh, I'm running out of room, ab. And let's just expand things. So expanding everything is going to enable us to see if we've got the same thing on the left hand side. You can see I now have got 2x squared on the same side, on both sides, sorry. 2bx minus 2ax plus 2ab. Alright, so let's do some cancelling. So the 2x squared and this 2x squared go away. It's only when they're exactly the same. Alright, so they're both positive 2x squared, so we can cancel out. Nothing else is the same, which is a bit annoying. Alright, so anything with an x in it, I'm going to bring to the left-hand side. So we've got minus ax minus bx can stay there. And then the minus 2bx on the right side comes over as positive, and then that one's also positive, and then the 2ab can stay on the right hand side. All right, now I can take out x as a common factor. And I probably could have, I've got some like terms there actually. So maybe underneath I'll do that because I'm running out of space, aren't I? All right, so we've got this minus bx and this plus 2bx. So if we've got 2bx minus bx, we're only left with 1b. You could do this in one step if you like. And then we've got 2ax minus ax, so let's underline them as well. Maybe we'll do them in squiggly lines, and that they're like terms. So 2ax minus ax is ax, so just a, because we've already taken the x out as a common factor. All right, the x stays. We divide both sides by the b plus a, or a plus b. So x is equal to, now I'm going to put it in alphabetical order, a plus b. All right, there's our final answer. Now, if you have a lot of working out, please put your answer in brackets. It just makes it a lot easier for me to work out where your answer is, because some of you write a lot, which is fine, but you are left thinking, what's your answer, guys? Just make it easier for me. Just let me find the answer. You know, I don't want to go on a little hunt. All right, question 2. So for the simultaneous equations mx plus 2y equals 2 and 8x plus my equals m, find the values of m for which there are infinitely many solutions. Infinitely many. So remember, that means they're the same line. Now, I'm going to show you 2 different ways of doing it. Now, I probably will give you these solutions, but my handwritten solutions from last year include the matrix method. Actually, it was probably the year before, because I didn't teach the matrix method, I don't think, last year. So I'm going to teach you the ratio coefficients, and then I'm going to transpose it in the form y equals mx plus c. So not worrying about the matrix method, because the ratio of the coefficients is pretty much the same as the matrix method. And once I start introducing matrices, if you've never seen matrices before, you might be a little bit scared. So let's just stick to these 2 methods. Okay, so when there are infinitely many solutions, it means they have the same gradient and they have the same y-intercept because they're the same line. So our first check is of the gradient, okay, because we're basically checking, and let me write it up here. All right, we have either parallel lines, they have the same gradient, or we have the same line, which might be a bit, just pretend those lines are on top of each other. So we've got 2 scenarios. This is scenario 1 and scenario 2, where the gradient is the same. To differentiate between those 2, whether the lines are parallel or they're the same line, we need to check. So always check whether lines are parallel or the same line. So when you're doing your methods, either method, you're first of all checking the gradient, and then effectively you're checking, well, if the gradient's the same, are my lines therefore parallel, or are they the same line? Okay, because both of those 2 scenarios, the gradient's the same. All right, so with this question here, we've got the coefficients of x, so this m here, over 8, and then the coefficients of your y. So we don't do the constant just yet, just those 2, because that's going to tell us about our gradient. 2 over m. Alright, and then we can just solve for m. So cross multiplying, we get m squared equals 16. So m is equal to plus or minus the square root of 16. So we've got 2 solutions, m equals 4 and m equals -4. Alright, so then we have to check. Alright, so when our gradient is 4, does that mean our lines are parallel, or are they going to be the same line? Well, in this case, we're finding the value of m. So if they're this, if we want infinite many solutions, it means they're the same line. So, and I might write this in red because we don't usually write it at the start. Coefficients of your constants, so 2 over m. So now I'm going to take this, all right, so we did that, the other part first of all, and now we're going to do this. So 2 over m equals 2 over m. Now they're actually the same here. So we've got whatever I can see now, whether I put in m equals 4 or m equals -4, I'm going to get infinitely many solutions. So so I would do usually a check. So when m equals 4, we get 2 over 4 equals 2 over 4. So yep, infinite solutions. And let's check the other one because I always should. 2 over -4, and that does equal 2 over -4. So when m is equal to equals -4 and m equals 4, we have infinite solutions. So that basically means you'll never have parallel lines, okay, because when your gradient's the same, it's going to be the same line, and that's because of these coefficients being the same. So this 2 over m and this 2 over m, all right, they just happen to be the same. Now, if the question asked for unique solution, all right, it means m can be absolutely any number your little heart desires except for -4 or 4. So for a unique solution, so let's write it down the bottom, a unique solution, so that's your answer there. Let's just write this down here. So for a unique solution, m is an element of any real value excluding -4 and 4. Now notice the squirrely brackets I use, okay, because you're talking about a set of values, not a range of values, okay. Now the other method you can do, and I do see a lot of students doing this method, so I assume that you've been taught it in year 11 and there's nothing wrong with it, is rearranging your equation into the form y equals mx plus c. Now the reason why this method is good, although it does require, I think, a little bit more work, and I prefer the other method, is you can see if you're rearranging, this is your gradient. So when your m is the same, your lines are parallel. Okay, so that's going to tell you whether you got parallel lines or same line or same line. So when your m is equal to your m, your gradient is equal to the gradient, you have parallel lines or the same line. Now when your c's are the same, so when your y-intercepts are the same, clearly it's the same line. Y-intercept same line, or you can have different y-intercepts, and that means we have different lines. Okay, now I'm going to just, actually, should I keep that on there? Okay, I might keep that in there. So with our rearranging, and I'm not a huge fan of this because I'm just like, Okay, so there's our equation. We need to put it in the form y equals mx plus c before we can see what the gradient is. So I'm going to bring that m over. I'm going to bring it over correctly. So 2y equals -mx plus 2. And then y is equal to -mx divided by 2 plus 2 over 2. Now you could tidy that up a little bit if you want to. This one. Okay, so that's for your first equation, numero 1. And then we've got our second equation. So we've got 8x plus my equals m. We do the same thing. So my equals -8x, oops, that should be an x, not an m. 8x plus m. So y equals negative 8x over m plus m over m. And when your numerator and your denominator are the same, all right, it's going to be plus 1. So I can already see that my intercepts are the same. Now, remember, as I said before, when your gradients are the same, you have parallel lines or the same line. So I'm just looking here at this coefficient. Oops, and I don't know why I wrote an x there, because that should not be x. That should be an m. All right, so I'm just taking those coefficients of x, so we get negative m on 2 is equal to negative 8 on m. And you'll notice, except for the negatives, that's what we got here, didn't we? Yeah? So you can see why my preference is for doing the ratio of coefficients. Now, I have come across questions where that method doesn't work, but yeah, I think the majority of the questions will work, and if it doesn't work, you just use this second method. So you can see all that rearranging that you had to do to get the negative m on 2 equals, so because there's a negative on both sides, we can just get rid of it. So basically what I have here, which took me quite a while to get to, if I just did ratio of coefficients, I had it straight away. So you can see why I prefer that first method. And then basically from there, and I might just write that in pen, not highlighter, as solution number 1. Okay, so rearranging it is fine, but you can see why you'll be more prone to making errors. And I've never seen, and it doesn't mean it's not going to happen, but I've never seen a question like this where your equations are not in this form, in intercept form. You know, your x, the y equals a constant. All right, they're not given to you in the form y equals mx plus c, often. Should not say always. But yeah, you can just see, like, that question, I'm only halfway. I only got to the point where my first solution starts. So I have to go through then that same process again. So it's taking twice as long to do that question. All right, question number 3. So this sort of question would be maybe on a SAC because you've got the time to do it. But not on an exam. If it was on an exam, it would be broken up into parts. And the reason for that is because there are so many steps involved that if you can't do one of them, and this wouldn't be, like, this sort of question would be worth quite a lot of marks. So let's say it was worth 6 marks. If you couldn't even get started, that's 6 marks you've lost. So questions like this, if they did appear on an exam, would start off with a show that. So it might say, show that the intersection between these two lines is. So basically, we've got a triangle. So if we read the question, find the area of the triangle. We've got to find the area of that triangle. Sorry, did I just say find the area of the triangle and we got to find the area of that triangle? We're going to be having a triangle. So if you've got 3 lines, all right, they're not obviously the lines, but there's our triangle. All right, in the middle. Now, a little hot tip, although it's not always going to be the case, it's probably going to be a right angle triangle, because then you can clearly see if we were using, and it's not going to be drawn like this, but your formula for a triangle is a half base times height. So there's your base and there's your height. So if it's perpendicular, it just makes it a whole lot easier, because if it wasn't perpendicular, let's say your 3 lines were formed like that, or it wasn't, when I said perpendicular, it was not a right angle, your height is this distance here, all right? And that just makes it a little bit harder, and that's your base. So this question, without even starting it, although I know I wrote it and I've done the solutions before, I would look at it and be like, I reckon those 2 of those lines are going to be perpendicular to each other, giving a right angle triangle. Now, with the equations, the easiest way to see if they were perpendicular is just rearrange them. So this one, first one's going to become y equals x plus 6. This second one, let's just do a little bit of rearranging. X on 2 minus 3 on 2. Now I've skipped a few steps in one. Let me just check. Looks good. And then this one is going to be y equals negative x plus 6. So my perpendicular lines are this one and this one here. Alright, and the reason I know that is because, I'll write this in pink, the gradient of this one is 1 and the gradient of this one is negative 1. They're the negative reciprocal of each other. The reason it's 1 and 1 is because if we wrote 1 as a fraction, it's 1 over 1. Alright, so 1 over 1, its reciprocal is 1 over 1. Alright, so they're your two perpendicular lines. So just a quick check like that, it's like, yep, that's confirmed the fact that it's a right angle triangle. Now, we need to find the points of intersection to find the distance between 2 points. So if you think about your triangle over there, let's just do a different colour. Alright, we've got these 3 points. So we need to do the points of intersection of 2 lines 3 times. So if I call this, let's just change this to pink, this is equation 1, this is equation 2, and this is equation 3. So let's find the point of intersection of equation 1 and equation 2. Now I've already rearranged them as y equals, so that makes it super duper, maybe just super duper, I don't want to say super duper easy, just super that we don't have to do it again. So there's the first one, just letting the right hand sides equal each other. Alright, and I do want to just check that I've done that correctly. I have. So we're solving for x. Bring the x's over to the same side. So x minus x on 2 equals negative 3 on 2 minus 6. And you're probably like, oh my god, there's fractions there. Yes, there are fractions, and just to make it a little bit easier, I would just multiply everything by 2 to get rid of that 2 on the denominator. I'm just making sure I have copied that correctly. So multiplying everything by 2 changes the x to 2x, the x on 2 to just minus x, the negative 3 on 2 to negative 3, and the 6 to minus 12. Alright, got rid of that 2. But to get rid of the 2, everything gets multiplied by 2. So what I did is we basically put brackets around, and that's times by 2, and that's times by 2. Alright, so 2x minus x gives me 1x, negative 3 minus 12 is negative 15. Now I've solved only for x, I need to get a y, so I can substitute it in either equation 1 or 2, because I did equation 1 and equation 2. So I can't do equation 3, because we're doing the intersection of equation 1 and equation 2. So just substituting it in, we get y equals negative 15 plus 6, which is negative 9. So my first point of intersection is negative 15, negative 9. Alright, so that's the first one. Let's get rid of these triangles over here because I might need the space. Now we're going to do the point of intersection of equation 1 and equation 3. Equation 1 and equation 3. Now it might be a good idea for you to actually pause and do it yourself. And then we're going to do equation 2 and equation 3. Alright, because remember we have 3 points of intersection. Alright, so yeah, if you haven't already paused, pause away, and I'm going to do the solution without talking. So when you pop back, hopefully you can just see the answer. Alright, good on you for doing those. I know you did. I'm hoping you did. Okay, so we've got our 3 points of intersection, alright, for our triangle, which we've got here. Okay, now we have to find the distance between them. Now, if you were sketching this, you do know you only need the distance between 2 points, because we don't need the hypotenuse, because we're only to do the area of a triangle, we only need the base and the height. So if I'm sketching, I might do just a quick sketch of this, just so I know which points are which. Okay, so 0, 6, let's just say there, 5, 1, it's kind of here, and negative 50, so I might just do that, 5, 1, probably should change the scale a little bit, that's a terrible scale. Let's just get rid of that. Alright, so there's the second point, and then we've got negative 15, negative 9, oh my gosh, guys. I've got to extend this. Whoop. Whoop. Alright, so let's say negative 15 is all the way down here. This isn't going to help, but negative 9. So our third point is here. So our triangle is something like that. Now, if you're wondering which line is which, so remember I numbered them up here, up the top. So line 1 and line 3 both have a y-intercept of 6, so I can label them, and then that means the third one's going to be the other one. Okay, so line 1 has a positive gradient, goes through 6, so this is line 1, and then this is line 2, and this is line 3. So remember, as I said before, the right angle is formed between, oops, wrong way around, silly Billy. This is 3 and this is 2. The right angle was formed between line 3 and 1. So there's your right angle. So we want this distance here, this distance, and this distance for this one. All right, it doesn't matter about the other one because it's just a hypotenuse. You could do it if you wanted to. You're wasting your time. And you'd have to work out 1 and 3. Actually, you could work out all of them without introducing... Yeah, I'm just thinking as I'm talking. I think a rough sketch like that just helps you see. And we already knew that equation 1 and 3 were perpendicular to each other because of the gradients. So that's how we know where the right angle is. And now we can do the distance between 2 points. All right, so this point here, remember, is negative 15, negative 9. This point here is 0, 6. And this point here is 5, 1. All right, so I'm going to just highlight this one first. So that's the first line we're going to do over here. And then do the other one in yellow. So there's your yellow line over here. So we're going to do the distance between 2 points. So we've got negative 15, negative 9, and 0, 6. And the other one's going to be 0, 6, and 5, 1. Now your distance between 2 points formula, remember, comes from Pythagoras' theorem. So the distance is equal to, x2, I don't know, sometimes it could be x1. Doesn't really matter which order you put it in. That's why I'm laughing at myself. As long as you get the x and the y is correct. And it doesn't matter if you did y first either, because we're adding them. So if we call this x1, y1, x2, y2. All right, and then I'm going to do the yellow line, x1, y1, x2, y2. All right, so doing the purple line first. And then maybe you can have a go at doing the yellow one. All right, so your distance, x2, 0, x1 is negative 15. Just be careful with your negatives. And then we've got y2, 6, and y1. Doing the square root. Just make sure your radical goes all the way over everything. So then we've got 15 squared, which is 225. And 6 plus 9 is 15, so 15 squared. 225. So that is 225 plus 225 is 550. And I feel like I've made a boo-boo somewhere along the line. Let me just check my answers. No, it should be 450. But I didn't make a boo-boo, I just couldn't add that one. All right, 450. Now, you should be able to simplify that surd. So what is the highest square number that goes into 450? So I can see I've got 225 in the previous question, so that goes, it's going to be 15. So the 450, I don't even need to do that. Let me get rid of that. So 225 times 2. That's going to help us simplify that surd. The square root of 225 is 15, so we have 15 root 2. Just on that, if you did have this question on an exam, I don't think they would give you a number so high to do the square root of, but yeah, it might take a little bit of thinking, but you probably should know what 15 squared is. Okay, so if you want to do the yellow line now, if I can get my highlighter, choose the right one. All right, so you do the yellow line, pause, and yeah, then check in on my answer. All right, I couldn't be bothered pausing the video, so let's just quickly substitute it in, and then I'll just give you the answer. So 5 minus 0 squared plus 1 minus 6 squared. So we're going to end up with, looks like 5 squared plus 5 squared again. Or when I say again, the same thing again. So 25 times 2. So we end up with 5 root 2. Now the area of a triangle, I don't have enough space. Let me do it down the bottom. It's going to let me choose a pen. All right, the area of a triangle is half times base times height. Now it doesn't matter which one you call your base and which one you call your height. So I might just call this our base and this one could be our height. All right, so we're going to have a half times 15 root 2 times 5 root 2. Now, the fact that they're both root 2 is fantastic because then that becomes root 2 times root 2 is just 2, so it's half times 15 times 5 times 2. 2 times a half, they basically cancel each other out. I wanted that first one in blue, excuse me. So they cancel each other out, so then we're just left with 15 times 5, which is, my friends, 75, and then we didn't have units, we could just put units squared. All right, very hard question, but I love that question. Lots of learning involved. Good stuff. Hopefully now going through that video you understand it. I know it's a long one, but well done for sticking out. Bye.